broken it somehow. Just so you have to fork out a lot.
Predicting population means. All right, predicting population means.
I put down predicting population modes.
Just as with categorical data. Just as with categorical data, the population mean, which is denoted with a mu, is always within two standard errors of the sample mean.
Yeah, I always feel confidence with this.
X bar. Given 95% confidence. Okay, so when we did categorical data, it was always based on a 95% confidence interval. We know that the population proportion, P, should be within two standard deviations. We actually did 1.96. 1.96 standard errors of the sample proportion, P hat. The concept applies also for predicting population means. If we do not know the entire population's average, average test score, we can collect a sample and we can predict the population from that sample, and we can report a result given a whatever noted percent confidence interval. Okay, whether that be a 95% confidence interval, 90% confidence interval, all the concepts apply. All the concepts apply. So we have percent confidence interval. It was the confidence interval for proportions was P hat, which is the sample, plus or minus Z critical standard errors of P hat. The percent confidence interval for means is going to be sample mean plus or minus Z critical standard errors of the sample.
P hat and sample mean the same. But
Correct.
Like,
P hat is when you deal with categorical. Sample mean is when you're dealing with quantitative.
so basically, P hat and X bar are like.
Go ahead. They're the exact same. Yeah. It just depends. It just depends on what kind of data you're working with. If you're working with categorical data, it's called P hat. If you're working with quantitative data, it's called X bar, because it's a numerical value, not just a proportion of the data set.
So there's
But yeah.
similar best for us.
So, yeah. Now, once again, one thing I forgot to put up here, guys. If we go back in our notes, which you don't need to, I said there's three ways that we can do this predicting population from a sample. The first one was categorical data, which is what we've been doing. The second one is quantitative data, and you had two subcases, where the population standard deviation is known, and there's also the population standard deviation is not known. Okay? Maybe we need to put here, predicting population means where sigma is known. And sigma is the population standard deviation. Okay, so this is subcase 1, if you will. Okay. We're dealing with quantitative data because it's means. Averages are quantitative data. This is subcase 1. And that's when the population standard deviation is known. If the population standard deviation is known, we're going to apply this confidence interval. X bar. What was P hat called in terms of? It was called the point estimate. This is still called the point estimate. It's your estimate for the entire population. So if you create a confidence interval, X bar should be where?
In the middle.
Directly in the middle. right? Because you're subtracting and adding the exact same thing to x bar, so x bar will always be in the middle of a confidence interval. Okay?
Sigma is not known.
Sigma is known. Sigma is known. If sigma is not known, we cannot use z-scores. It's something else.
Is the confidence going to have a margin of error?
No. Hold on. Yes, sir. Yes, sir. Hunter. Which Hunter asked? Mr. Taylor needs you real quick.
Never mind, Mr. Hand.
This whole thing here is the margin of error. Okay? Remember, it was margin of error is equal to z critical standard error of p hat. So the margin of error formula for quantitative data is z critical standard error of x bar. It's the exact same formula. It just depends on the data type that you're working with. Z critical is based on the percent confidence interval. Right? Z critical is based on the percent confidence interval. If we're looking for a 90% confidence interval, that's going to have a different z-score than a 95% confidence interval. And the standard error of x bar. Well, what was the formula for the standard deviation of x bar?
Square root of times q.
Now, listen to what I'm saying. What's the formula for the standard deviation of x bar? Not standard deviation of p hat.
Oh, is it?
It's square root, sigma over square root of the number of.
Sigma over radical n, right? Sigma over square root of n. Well, in this subcase, do we know sigma?
Yes.
Yes. So that formula stays the same. Sigma over square root of n. If you know the population standard deviation, then the standard error formula is the same as the standard deviation formula. Okay? We didn't have that same formula for the standard error of p hat because in order to know the standard error, the standard deviation of p hat, you have to know the population. And we didn't know the population. We were predicting it. Okay? So that's the formula. Once again, this is if this is known. Okay, we will get to what if that's not known. Okay? And that's a whole different topic. Okay? It's a different subcase. If that's not known, this formula doesn't work. So we've got to have another way of handling it. But if that's known, here's our formulas. So, here's an example. Okay. Let's look at let's make it easy. 49 families in Adams County were asked their annual income. "49 families in Adams County were asked their annual income. The average income was $39,000. With a standard deviation of $15,000. $15,000. There are a total.
Wait, that was 15.
This is 15. I'll just rewrite it.
It sounds like 45.
It does. I agree. 49 families in Adams County were asked their annual income. The average income was $39,000 with a standard deviation of $15,000. Okay, if you were to go ask 49 families their annual income, they're going to give you 49 different incomes, correct? We could take that 49 incomes, we could put it into the R program, and just type in mean of data, and it's going to tell us their average income, right? We can type in standard deviation of data, and it's going to tell us the standard deviation of that data set. So this is something we could go out and collect and figure out, okay? Rather than me giving you a list of 49 data points, though, I'm just telling you, here's the results of it. Does that make sense? Okay, there are a total of, I don't know, does anyone know how many people in Adams County?
There's 20,000.
It's like right around 20, 30,000. Yeah. Okay, so let's say there's 20,000, and let's say the average family has 4 people in it. There are a total of 5,284 families. This is completely making it a up. Okay, I have no idea how many families there are in Adams County. Okay, we're just going to make a rough guess that it's around 5,000 families. So I'm going to say 5,284 families. So, can we use our data set to predict the entire county? If we've asked 49 families, I know I haven't put the word random up here, but if it's not given, then we just assume, right? Independence and random. Have we asked more than 10% of the population?
Yeah.
No, we've definitely not asked more than 10%. We've definitely not asked, did you say yes? Have we asked more than 10% of the population? No, 49 is not more than 10% of 5,300 people, 5,300 families. Okay, and the 10 success, 10 failure rule doesn't apply to this kind of data because it's quantitative. Okay, so we can use this sample to predict the entire county. And let's say we know this. The Ohio State Office reports that the average income of Ohio families is $41,000 with a standard deviation of $12,000. If we're collecting 49 families in Adams County, we're looking at a sample of 49 items. If they are just families that are in Adams County, does that give us the ability to make a prediction about the entire state? No, because if you're asking just people in Adams County and you're trying to make a prediction about the entire state, that's definitely not random. Does that make sense? If you say I want to predict the whole state and I want to use 49 families in Adams County, you're only looking at a certain part of the state. So it's definitely not random. But we can use the 49 families to make a prediction about the entire county. Does that make sense? So we can use this set of 49 to make a prediction of, we are 95% confident that the average family in Adams County makes between X and Y dollars. Okay, we can report that for Adams County. So, report. Let's not do 95.
Let's do 82. 85.
Let's do
16.
92% confidence interval. Something different for Adams County. I mean, you're probably getting to where you know 95 is 1.96. 90 is 1.65. Those are typically the most two that are used. But I want to make sure you're not losing track on how to come up with z-critical. So we're running 92 just for the sake of being able to calculate z-critical.
Yeah, I have no idea how to do that. I just had to memorize them.
Report a 92% confidence interval. Here's our formula. X bar plus or minus z critical, standard error of X bar. We need to know all this information. X bar is our point estimate. X bar is our sample mean. Reading through this problem, what's the average of our sample? 39,000. Okay? X bar, the average of our sample, that's the sample mean, is 39,000. Define Z critical. Remember, Z critical is based on your confidence interval. Here's Z critical, here's negative Z critical. How much data are we wanting to fall between those two? 92. If 92% of data is between them, how much is on the outside? 8. That means each of these makes up a total of 4%. So 0.04. So in terms of p-value, what's the p-value? 0.96. Going to the chart. You go to the chart. To find the z-critical, you're looking for a z-score, so you go to the middle of the chart. You find the closest p-value to 0.96. 9599 is the closest one. That's a z-score of 1.765.
How'd you get 0.96?
Because you take the 0.92, 92% between, and you add the 4% that's to the left. You always add it. Yep. Because in order to use the p-value, you got to know the total area to the left, and 92% is just between these two. In order to do p-value, you got to know the total area to the left. So we've got to know what this chunk is, and it's always going to be half of what's left over from the confidence interval. Someone in the back, Caldwell. Caldwell, you started to ask something.
I explained it to her for
Okay.
once. I knew the answer.
So z critical is 1.75. So we know x bar, we know z critical now. Now we got to come up with the standard error of x bar. Okay? It is this formula, provided you know the population standard deviation. We do not know the population standard deviation for Adams County, but later in the problem it gives us the population standard deviation for the entire state. What is that?
41.
The Ohio State Office reports that the average income of Ohio families is $41,000 with a standard deviation of $12,000. This is a state report. We can treat that as the population standard deviation. It is. We won't use it at all. Yeah. The 15,000 doesn't get used at all in this case. It's irrelevant. If we did not know if we did not know the state average had a standard deviation of 12,000, then that 15,000 becomes important. But since we know it, that 12,000 represents the whole state. That's a better estimate to use. And that's subcase 2. Julia, subcase 1 is when the population is known. Subcase 2 is when the population is not known. So subcase 2 is where we'll use that 15,000. Okay? So this is going to be 12,000 over the square root of,
49.
is it 49 or is it 5,284? It is 49. It is 49.
That's because my word.
Because N is sample size. How many people is in our sample? 49. We're interested in making a prediction about all of the families, but we're not looking at all the families. We're only looking at 49 of them.
We explain the 12,000 again. Like why it's not 15,000.
Because sigma is the population standard deviation. So although our sample had a standard deviation of 15,000, the state office is reporting a standard deviation for the entire state. So we have more of a population standard deviation than what our data is. So it's better to use that.
So like you can use the other ones, but it's better.
It's a whole different formula.
Okay,
It's different formulas.
Okay.
It's different formulas.
Yeah, more memory.
12,000 divided by 7. Anybody have that?
1,714.285. Okay, guys. We good?
0.289? Okay, I'm going to just do 0.29, right? Because if you're talking about money, you have $1,714.29. Okay, that's the standard deviation. We're going to plug all this into our formula. X bar, 39,000. Plus or minus, Z critical, standard errors. So plus or minus 1.75, 1,714.29. We're going to work out both of those. 39,000 minus 1.75, 1,714.29. You get, well, basically 36,000. That's kind of weird. That worked out to be that nice. Okay, that's the low end. And if we go up here and we change this to a plus, we get that the high end is 42,001 cents. So basically 36,000 to 42,000.
If I would have got that answer, I would have kept doing it.
Yeah, that doesn't happen very often. So, report a 92% confidence interval for Adams County. So we'd say, based on our sample, and if you ask a different 49 people, you will get a different result. Based on our sample, n equal 49. You always have to include the size of your sample. Based on our sample, n equal 49. We are 92% confident, which just sounds weird. We are 92% confident the average family income of what? Ohio or Adams County?
Adams County.
Of Adams County. Because if you ask just people in Adams County, the only prediction you can make is about Adams County. If you wanted to make a prediction about the entire state, you'd have to collect data from all of the counties in the state, where it's randomized. That's my master's thesis. That's what we're doing. We're looking at school districts across the state. And so we're not doing what I told you
So we're
about.
doing the same thing?
Yeah, we'll be working on it until next summer. It's going to be anywhere from 60 to 300 pages long.
60 to
Is that the
300.
big- 60 to 300. Yeah, 60 is. If you do just the bare minimum, it works out to be 60. I mean, just by having all the data listed and all the tests listed and all the graphs, just like your guys' midterm papers, where most of them was like 8 pages. There wasn't really that much typing, but just getting all the graphs in there took up 8 pages. So yeah, just including all the data and doing all that, it'll take up 30 pages and stuff. Huh?
You said till next summer, like, do you guys spend, like, I'm gonna write this word today.
Well, we've got
I'll
to.
write the next word tomorrow.
It's 60 to 300 pages. We got to. It's not just running one 95% confidence interval. We're talking about looking at a data set of 680 schools. There's 680 different schools, and we're not just looking at one variable. We're looking at like 20 variables. So when you do the math, that's 13,060 data points.
Who's doing more work?
Well, R is doing the most work.
What?
The R program.
Oh, okay.
But no, we just split it up. Okay, so based on our sample, we are 92% confident the average family income of Adams County is between, and we'll just say 36,000 and 42,000.
Sounds like you make that assumption.
Now, so then the question would be, okay, so another way that this question could be asked is, does Adams County seem to be poor in comparison to the rest of the state? Well, what's the average of the entire state? 41,000. We're 92% confident that Adams County is between 36 and 42. Is the state average inside of our interval?
Yeah.
Yes. So based on our interval, can we say that Adams County is a poorer county compared to the entire state? No, because the state average is inside of our interval, based on this interval. So, I mean that's not part of this question, but if you could easily turn that into Adams County does not seem to be a relatively poor county in comparison to the state. Now, once again, I've made those numbers up, so if you look at the true numbers, it might have different results.
I was watching the news.
And actually, this school district is called.
I didn't complete it. Sorry.
Our school district is considered a socioeconomically disadvantaged school district. And the reason how that's calculated is it figures out what school districts are below the state average. Give me a second. I'll work through this problem. 36 students at West Union High School got an average of 19.2 on their ACT. Standard deviation of 1.2. ACT.org reports the national average is 20.8 with a standard deviation of 4.8.
Wow.
Is the test just going to be over
It's
quantitative
everything.
data and categorical data about this?
Yes.
Is that it?
Yes.
I mean, we can already tell them everything.
Okay, so
I'm sorry.
if you look at the 19.2, the 19.2 alone is not enough to say they're underperforming because it's a sample. It's not the entire school.
Okay, I'll ask first.
So, we're going to create, is West Union High School underperforming? It does not say, it says, is West Union High School underperforming? It does not say what confidence interval to run. If it does not tell you, you just always run a 95% confidence interval. If it does not say run this confidence interval, the general rule of thumb, always do 95% confidence.
So you could totally give that paragraph, not ask an entire question, and we should automatically do 95%.
Correct.
Again, it's weird.
Yeah, because it's just the general rule, because that's that empirical rule, 95% of the time. So we just always use 95% confidence interval.
I don't ever do. Like,
We're going to create a confidence interval. We need to be able to fill in this information. Sample mean, plus or minus z critical standard errors. The sample mean is given to us. What was the sample mean? 19.2. We're interested in the 30. We're looking at 36 students at West Union High School. Those 36 students average 19.2. That's our sample. So that's our sample mean. Z critical 1.96. We've done that one. 95% confidence interval. Z critical 1.96. That's something that should be memorized. If it's not, you can do that method to find it, and you'll get 1.96 every time. The standard error of x bar is population standard deviation divided by square root of n. Now we know that our 36 students averaged or had a standard deviation of 1.2, but ACT.org tells us that the national standard deviation is 4.8. That's the better one to use. It's the national. That represents the entire population. So if you know the entire population, it's better to use that. Okay, this is subcase 1. If you know the entire population standard deviation. So it's going to be 4.8 divided by the square root of 36. We're looking at 36 students' average ACT score. Square root of 36 is 6. 4.8 divided by 36 is 0.8. We have everything we need to create a confidence interval. It's 19.2 plus or minus z critical, which is 1.96, standard errors, which is 0.8. We're going to type this in, 19.2 minus 1.96 times 0.8. We get 17.632. And then we're going to go to that same equation or same expression and change that to an addition sign. Now, the question is, does West Union High School seem to be underperforming? What did the entire nation average? 20.8. So you ask yourself, is the nation part of our confidence interval?
No.
No. Okay, so what we're saying is our confidence interval is saying we are 95% confident that all the students at West Union High School average between a 17.6 and a 20.77 or 20.768, right? We're 95% confident that if you're asked all the students at West Union High School, it's between these two numbers. Is 20.8 included in that? And the answer is no. So does it seem that West Union High School is underperforming?
Yes.
Yes. But if you notice, if you rounded this 20.768 to just a single decimal, what would you get? 20.8, but it's still no. Because that's making the assumption that you're rounding. Okay, this is 20.800.
Never, ever, ever round.
Well, if you round it, works out to where it's just on the tail end. But if you don't round, it doesn't work. So yeah, you can't just say, okay, let's round.
So never round.
This
Yes.
is another case where you can use persuasion.
So do what?
It's like another case where they can use like persuasion, and you could say like, oh no,
Yeah,
like,
because
fine grit, you round it.
yeah, we rounded it. Yeah, that's right.
Or
So
you can
so you can say
Okay, so let me rephrase this. Do you want us to round?
Some passages. Like cake.
okay. So
So if we use the Z critical as 2, we'd get a 20.8.
That's true. Yeah. So if you use Z critical as 2, you will get 20.8s in there.
So therefore, you can
So-
like if you did a 9-9.
If you did, no, 9 makes the confidence interval smaller,
So
not
if you did-
bigger. So if you did a 90% confidence interval, you could say I'm 90% confident, and then therefore based on 90% confidence
We're
interval,
not. West Union's not.
West Union is not underperforming. Yeah. Because when you
I thought
decrease,
the higher the percentage, the larger. The
I'm
lower
sorry, you're right. I said that wrong. You're right.
And that
Increase it up to 97% confidence interval. Yes, that will allow you to say we're not underperforming. Okay. Now, guys, this won't happen on the test. This being this close, but this is questionable. Okay, we're talking about the very endpoint of our 95% confidence interval is almost up to the national average. I mean, it's 10. So it's questionable on whether or not. So if we wanted to say, okay, this seems questionable, this seems like an issue, we could conduct a better survey. So if we want to take care of this, but this is questionable, what do we just need to do? Ask more
this
people.
question.
Yeah.
This question.
Ask more people. Increase sample size. Okay, when you increase the sample, it's going to give you a more accurate prediction. Now, here's the dilemma. When you increase your sample, if you increase your sample and we are underperforming, that's going to take this confidence interval and drag it, what, up or down?
Down.
It's going to drag it down. If we are performing at what's considered the national level, that's going to drag it up. So increasing the sample size, it's going to take it from being questionable to say, yes, they are underperforming, no, they're not. So it just depends on your sample though. You might ask, and you might, even if you ask 30 more people, you might get the same results. Okay, it might not change at all. But the best chance to get rid of this questionability is to just go ask more people, increase your sample size.